But for now we have done the 4 pieces, and the last part which I want to talk about here is the routing piece, right? And when you're talking about the routing piece, I also want to talk about a very interesting feature called as active active forwarding. This is a very interesting feature as well. So these are like two very good features of VSX, right? The two features, one being your active gateway and the other one being the active forwarding, right? These two are two separate features, and I wanted to kind of stress on that, right? But before that, let us, before even coming to what active forwarding is, let's do the routing piece. The routing piece is pretty straightforward, right? So we'll put a VLAN here, right? We'll make all these ports as we'll basically put a new VLAN 101, right? We'll put an IP here, we'll put an IP here, we'll put an IP here, and we will enable OSPF between all the three guys, right? And we'll enable OSPF. We'll redistribute the existing VLAN subnets into that OSPF, and that way, all the endpoints, basically this external router will be able to talk to this H7, right? That's the whole goal. So we'll enable this VLAN to begin with, right? And then we will talk about what this active forwarding feature is all about, right? So let's come back here. Let's come to the spine. Okay. So on the spine, only thing you have to do is we will start by, let's clean the screen. All right. So let's go here. Let's clear the screen a little bit. So let's start by configuring OSPF, right? So we have router OSPF 1. Let's put our router ID, right? Let's say 2.2.2. Let's redistribute everything which is there, right? So I'm going to redistribute connected. So all my VLAN subnets are going to get redistributed. Area is going to be 0.0.0. Now all you got to do is we create this new transit VLAN 101. Let's put a IP address on it, right? So we shouldn't, because we'll be enabling active forwarding on this one later, we should not be enabling active gateway on this, right? So let's go with 10.1.101.2/24. Let's put this in OSPF 1 area and 0.0.0. No shut, right? Perfect. So that's the VLAN. Now we also need to create a multi-chassis Ether channel here as well, right? So we'll be putting these two ports, and we'll create the lag over here. So this also will be a multi-chassis Ether channel, right? We have done this a lot earlier, so this is going to be pretty simple. I'm going to do lag 2 multi-chassis, right? And it's going to be just an access port in 101. LSCP rate is going to be fast, and it's going to be no shut. Okay. The interface 1/1/3 is going to be put in that particular lag 2 and no shut. Alright, so that's the main config. Let me replicate, give me a minute, let me pause and replicate the same thing on the other spine as well. Alright, so the same configuration is done on my spine 2 as well. Let me probably clear the screen just to show you that. In fact, let's look at the configs on spine 1 and spine 2. Let me clear the screen. So mainly let's do no paging and show run, right? So we just enabled the routing here, and we added the VLAN 101, right? And we also created the multi-chassis lag, which was lag 3, I believe. Was it lag 3? Let me scroll top. Yeah, so there you go, lag 2. I think lag 2, this is what we created, right? And we put the 1/1/3 on lag 2. Same thing here as well. If I do show run, right? Exactly same. So you have the router OSPF, just the router ID is different. And then the 1/1/3 interface has been put under, let's go there, 1/1/2. My bad. Okay, 1/1/3 has been put under lag 2, right? That's the only config which is done. All right, so so we have that, and then what we have also done is the server, right, which we, or the router which we have here on the top, that has been configured as well. Let me show you that. So that was already configured in the past, so you can have a look at that. Very straightforward configs. We just have VLAN 101 and the two interfaces 1.1 and 1.2, right? So they are going to be put under this. The lag here is not a multi-chassis lag, because like I said, on this particular router it doesn't really know what is there on the other side, right? So this is a tip, it's a normal lag, it's not a multi-chassis lag, and you have the VLAN 101 configured with the IP of this thing, right? So ideally from this router now we should be able to ping the SVIs which we have, like 10.1.10.1 is pingable, right? Let's try 11.1, also works, 12.1 also works. Yeah, so you can see the connectivity is there, right? The routing also should be good. Show IP OSP of neighbors. You can see the two neighbors, right? Looks like 2.2.2 is the DR, right? Whereas 3.3.3 is the BDR, right? So everything is good from OSPF perspective is good, right? Great. So ideally, I mean, I still feel, I think, I will have to probably restart all these simulators for the complete data part to work from H7 to external. Maybe I will try that at the end of the video. But for now, one thing I want to kind of touch base is what is this whole feature of active forwarding. Right now we have not enabled active forwarding, but I want to explain what it is before we get to it. All right, so the active forwarding, let me grab my pen. The idea is pretty simple, right? Again, and also a very supremely useful feature. It's basically an optimization feature, right? So what do we have is, right now in our topology we have a router here, right? So we have a router and we have the two spine switches, S1 and S2. What we have done is we have enabled OSPF, right, in this manner, right? So we have enabled OSPF over here, which means what is really happening is all these subnets which are present here, right? So we have the VLAN 10, 11, 12, 13, right? So all these subnets have been advertised into OSPF, and as a result, this guy is able to see these subnets. This router is able to see all these three subnets, all these four subnets. And if you remember, the next top IPs here are going to be 10.1.101.2, and this is 10.1.101.3, right? We can validate this if we go out to the router, on the external router. If I do show IP route, right, you can see for each of the subnets you can see .3, .2. These are ECMP paths, correct? ECMP, equal cost multipaths, right? So in order to route to these subnets, it can either take this guy or this guy, right? Either of them. Also remember, we have this multi-chassis, which means this router and this spine layer, right, it is logically appearing like this, right? Just one port channel of sort. Now because of this, what can happen is, when this router wants to talk to maybe say something which is here, right, like an endpoint, let's say the endpoint is 10.1.10.100, so it wants to talk to, the router wants to talk to this guy. What will router do? Router will look at his routing table. When it looks at the routing table, it finds two paths, right, two ECMP paths. One is towards .2, one is towards .3, right, .2 and .3. Okay, let's assume that it picks the .3, right, because it is ECMP, right? So it can pick any of them, right, because both are equal cost multipaths, and it obviously does like ECMP. I mean, it will send one flow on .2, one flow on .3. So let's assume that for a minute it picked .3 to talk to this guy. Okay, and once it has picked .3, the next what it is going to happen. So based on so it knows the L3 IP. Now it has to obviously forward that there is only one link between R3 and this, right, which is the port channel. So it is obviously going to figure out, again, it is going to use the port channels hashing algorithm, and it will let's assume that for a minute that it will pick one out of these two links. It is going to pick this link, right? It wants to talk to .3, but because of the hashing algorithm of the port channel, let's say it's going to pick this link. Now if it picks this link, what will happen is the packet will arrive here on S1, but S1 also knows that it doesn't own .3, correct? S2 owns .3, so it will have to send that packet on the ISL link all the way to S2. So you see there's an extra hop here. Okay, so with the active forwarding feature, what happens is, so with the active forwarding, once you enable active forwarding, both the spines will know about each other's IP and MAC addresses, which means S1 will know about 10.1.101.3 and its corresponding MAC as well. Okay, Similarly, S2 will know about 10.1.101.2 and its corresponding MAC. Right? What is the use of this? The use of this is, this time, same scenario, right? The router wants to send the packet using the .3 ECMP, but it is sending it to S1. But because S1 already has the mapping for .3 and the MAC address, it can answer, right? It doesn't have to, forward this along this, rather it can send it directly downstream. You see, because of that, this particular extra hop has been eliminated. Cool. So that's the main advantage of this active forwarding feature. With the active forwarding feature, both the VSX devices will know the IP and the MAC, right, which is configured on each other, right. As a result, it can answer those packets. It can forward the packets without having to send it on the ISL, right. Basically the whole point is to reduce the extra hop which is present. Okay, so we'll configure that. So only thing for the configuration of that is you just need to go and enable it in the SVI. So we'll just go to interface VLAN, but before that we also need to enable disable ICMP redirect for that to work, right. So we'll do no IP ICMP redirect is important. Let's copy this, let's enable that on the other switch as well, right. And next is you gotta go to interface VLAN 101, and in order to enable it you just need to do VSX active forwarding. Okay, same thing on this guy, interface VLAN 101, and you say VSX active forwarding. Okay, so once that is done, what you will see is, let me clear the screen, show VSX thing active forwarding interface VLAN 101, enter, right. So you can see now, though my IP address was, what is my IP address? Show IP interface brief pipe include 101, right. So if you remember, my IP is actually .2, but you can clearly see here from the show command I also have the information about .3 and its MAC address, correct. The same thing is, if I copy the same show command and run it on the other guy, you can see it has information about .2 and its MAC address. So they both have that knowledge right now. So as a result, they will be able to serve the packets, and that extra hop can be eliminated. Okay, so that was the routing piece. All right, so I think we've covered everything which I wanted to do. I still want to do a end-to-end, packet from, send a packet from H7 to the router. But for that, I might have to reboot all these machines, right? So give me a few minutes. I will just pause and see if I can do that. Sometimes, it might not really work, but let me give it a try, right? So the CX simulators are a bit finicky that way, but let me try. All right, guys. So I was able to, I think, fix everything. So what really happens is, what you really need to do is remove the interfaces from the port channels, shut all the boxes up, right? Bring up the boxes back up, right? And then put the interfaces back in the port channel and do a no shut on the interfaces, right? So when you do that, you can see all the interfaces start showing up. As you see here on spine 1, the lag 1, lag 2, everything is up. Similarly on spine 2, everything is up. On leaf 1, things are up. Leaf 2, things are up. And then on the external switch also, you can see things are up. Even on the H7, things are up, right? So now if I probably do a ping from the H7 to first to the default gateway, right, it is working. If I do a ping to the external router, which is at 101.1, that also works, right? So this is just a matter of shutting the CX simulators and getting it up so that the data plane kind of resets, right? All right, so coming back, just to kind of summarize what we have achieved in this video, or probably multiple videos, never know, depends on how big the video looks once I kind of decide to upload it. But overall, our goal in this video was to kind of build a topology which kind of resembles your traditional data center, and we tried to do that using this topology, right? Step number 1, we actually ended up creating we actually configured the management interfaces of all the devices. We have a management switch here. The next is we brought up the VSX. We brought up the VSX on the spines as well as the leaves. Then we enabled the VLANs which we need, right? While enabling the VLANs, we also explored how the configuration sync happens between the primary and the secondary VSX device. While we enabled the VLANs, we also enabled active gateway, right? Because the spines are going to be the default gateway. So the SVIs, we enabled active gateway as a feature, which means we get like an active forwarding instead of active standby, which comes with VRRP, right? So with the whole VSX technology, right, you can create multi-chassis lags, and then because of that multi-chassis lags, you can also create active gateways, which is basically nothing but default gateway, but which works in a very active fashion, right? So the very next step was to create obviously all the multi-chassis lags. I showed you how to create multi-chassis lag in an environment where you have something here at the bottom, right? So at the same time, we also talked about how to create like back-to-back multi-chassis, right? Where you have all these 4 links should be you have multi-chassis on either of the sides, right? So you have 2 spines acting as 1 spine and then 2 leaves acting as 1 leaf. So how do you create multi-chassis between them? So all these 4 links, we kind of bundled them together and created the lag 1, right? Then we went ahead and added some layer 2 features like spanning tree protocol, right? We configured spanning tree with our spine being the spine layer having the priority of 0, and the leaf layer or the axis layer having priority of 1, or I think we did not configure the priority, so it's going to use the default priority, but basically we made the spine layer as the root, whereas and then we also checked that we also used MSTP way of configuring spanning tree. We enabled security features like root guard, we enabled BPDU guard, we enabled admin edge feature, which is similar to port fast. And we also explored that when you enable spanning tree, the lags, right, the lag 1, which is here in the middle, is always forwarding, which means all the links are forwarding and nothing gets blocked because of spanning tree, which is one of the important feature of VSX. And finally, we enabled routing, right? To enable routing, we went all the way up. We used a transit VLAN and we enabled routing. And we also explored how using active forwarding can prevent the extra hop which the traffic will have to take without it, right? So active forwarding is a very interesting feature in itself. Okay, so hope that was kind of useful, right? So this is again, I just wanted to concentrate only on the collapsed cores LAN side. We did not talk about storage and any other components in a data center. We just concentrated on the switching and the routing piece and some of the top or at least the minimum configurations and features which are needed to get like a very small collapsed core pod up and running for you, right? There are obviously a lot of other things which we can do, a lot of new features we can turn on and optimize it further, but the goal of this video was to talk about a traditional data center, not a VXLAN, not a BGP VPN, just a typical traditional data center with like just an access layer and a core layer, and how you can do the L2 and L3 with some very minimum required features in a setup of this sort. Alright, so hope that was useful, and do come back for more videos. Have a good one, guys. Bye.